Hello and welcome back to Psychology 303, the analysis of everyday behavior. I'm Dr. Wendy Williams, and this will be the last lecture for Chapter 7. This is Lecture 7C on stimulus control, and we'll be talking a little bit about tips for teachers to finish up that lecture. So I wanted to start with the three types of generalization. Now remember, stimulus discrimination means we treat stimuli differently, and generalization means that we form a class and we respond to stimuli that are similar to the ones that are familiar to us, and so we generalize what we know about stop signs in English to stop signs in other languages, as long as they are, eight-sided, 6 or 8-sided red signs in the right places on the road. So the ability to take your stimulus control and use it in new environments and with different people is really important. So being able to use what you've learned in other places. So stimulus discrimination is important for learning specific behaviors that go with specific kinds of stimuli. And generalization is important so that we can use those skills effectively when we find ourselves in situations with similar stimuli. So in terms of generalization, there are three kinds of generalization. There's response generalization, subject generalization, and stimulus generalization, and I'm going to talk about each one of these. So the first one is response generalization, and it refers to the tendency for a behavior pattern to generalize to other behaviors. So we have one behavior, and it applies to other behaviors. It often occurs in verbal learning or and in very typical, normal, everyday behavior. So like Freudian slips of the tongue where we accidentally use the wrong word. Children who are learning language when they're very small will overgeneralize verb conjugation rules. So instead of, they'll learn that you put the word ed on verbs and it makes it past tense. So work becomes worked, play becomes play. So they overgeneralize and they will say, oh, he eated or he goed, by adding those the ed onto other verbs, onto irregular verbs. And so that's a pretty common way to see this sort of response generalization. We take that behavior and we apply it in places maybe where it shouldn't be used. Response generalization can be a good thing. We want people to take behaviors that they've learned and apply them to other settings. We want them to be able to use those behaviors in other situations. So we'd like to see both stimulus and response generalization in our clients. When we are teaching someone certain behaviors, we'd like to see them extend them beyond those new behaviors, beyond just the setting that they've learned it in. So people who have gone to therapy for having a phobia, like a fear of flying in a large plane. So say I do have fear of flying, and so I go to a therapist and I learn how to use my deep breathing and systematic relaxation, and I learn to overcome my fear of flying. But afterward, I use the same techniques to overcome my fear of elevators, of high buildings, and maybe bridges. So I'm able to use those behaviors that I learn in one setting in other settings that are similar but not quite exactly the same. It's been shown that people who break the law and are being trained to observe the speed limit, so people who speed and get caught, are also more likely to, after they've gone through training and after they've started obeying the laws, the speed limit laws, are more likely to wear their seatbelt than they were prior to the interventions, and to use their child car seats appropriately. So they're not really, what they learned was how to obey the speed limit, but that's a safety issue, and other safety behaviors kicked in. People attempting to change their exercise patterns may also adopt other healthy behaviors. We know that when people start to exercise, one thing that they tend to do is they tend to eat healthier meals. So response generalization can benefit from explicit generalization training. So we can, we'll talk a little bit about generalization training, but you can, if you really want a behavior to generalize, you can train it associated with one kind of response. So you could show someone, this is how you learn how to overcome flying. Now let's go to the Seattle Center and go up the Space Needle. And I want you to use those same behaviors to overcome your fear of the elevator or of the high building. And you can actually train them. And then when they're faced with a new situation, they're more likely to use those behaviors. All right. The second category of generalization is subject generalization. This is a very odd phenomenon, but it does occur. This is where you are in a setting and you are working with certain individuals who've been targeted for behavioral intervention. And as their behavior changes, you find that other individuals who are not being treated change their behavior as well. We often see this in classrooms where you target a couple of kids and get them going, maybe using a special reinforcement system, and then suddenly other kids are trying to earn those reinforcers too. It happens in residential care facilities. It happens in nursing homes, in the military, in group-based therapy. It's very interesting that you treat a few people and others try to jump onto the bandwagon. Others see your clients and students learning new behaviors and earning new forms of reinforcement, and so their behavior starts to change as well. And it's probably tied to our human tendency to learn through observational learning. Now, subject generalization can be very useful, especially in situations where you're working with a large group of people, like in a classroom setting with children. When you target a few kids for change using, for example, positive reinforcement, and other kids start to change their behavior as well, it can lead to increases in on-task behavior across the classroom. It can lead to improvements in compliance, in reductions in outbursts, in more cooperation. You can start to see a lot of behaviors start to spread. And so that's really great, that it spreads to other people and it spreads to other behaviors. It can also be very useful when you're trying to convince a teacher to try a new methodology, to try something different. You know, one of the first things that new teachers will say is that, you know, you can't manage the behavior of just a few kids in a classroom because you got all the kids to take care of. But what's really amazing is that you can treat just the few serious problem kids and you'll start to see the whole class start to change their behavior. And if you do this on a few students and you see others changing their behavior as well without you having to do the intervention, that can be all it takes to convince a teacher that it's a good idea to do something like this and to do individualized work with just a few kids, because other kids will just hop right onto the bandwagon, which is kind of, it's kind of cool to watch it happen, but it's also, it's a great selling point when you're trying to convince teachers to use behavioral interventions in their classrooms. Now, the third type of generalization is something that we call stimulus generalization, and this is the ability to respond to other stimuli in the environment in the same way that we treat our training stimulus because they're reasonably similar. This would be things like learning how to answer a new cell phone. You don't really have to learn a whole lot because you're applying behaviors you learned previously to a new product that's similar enough. When you come to a new stoplight, you know, if you rent a car and you drive to, I don't know what, Tri-Cities, and you've never been to Tri-Cities before, and you come to a stoplight, you know to stop because it's similar enough to the ones that you've seen in other places. Huge one, knowing how to study even though it's a new class. So you're learning some new kind of study methods in my class, and maybe you'll be able to take some of those with you to your next class. So I've trained you to work on vocabulary using a term test, And if you take behavioral neuroscience next quarter, that has a big vocabulary, odds are pretty good that if you made flashcards this time, that maybe you'll use flashcards in your next class to learn your vocabulary. So you'll get that new words, you still get the same behavior. Telling time on a new watch, it does take a little skill to go from analog to digital, but to go from one form to another, to go from one analog watch to another analog watch really isn't that hard. One might be, and I'm sure you've seen the watches that have so little information on them that they're almost impossible to read. So if it gets too different, then maybe you won't get the behavior. Learning how to drive a new car. Whenever you get a new car, you have to learn all the new things, but there's a lot about your old behavior that you're able to bring forward with you. All right. Now, one of the issues that comes up when we're talking about stimulus generalization is what happens if it doesn't work? What happens when stimulus generalization doesn't actually happen? Sometimes we have to then decide to train the individual how to generalize in order to ensure a therapeutic effect. I mean, if they're only going to use their new behaviors in the therapist's office, it's not going to be very effective. So sometimes we have to actually do more training with them to get them to learn how to generalize to other responses or other stimuli. And this is usually accomplished through something that we call multiple exemplars. So we train them with many different examples during training. So if I was working with an individual with, Down syndrome and training certain behaviors, I might work as a therapist, and then I might have the child's teacher come in and be the therapist and run the session, and maybe have one of the parents come in and run the session. And by doing that all in the laboratory, then when the individual gets back out into the world, having another teacher step in or the other parent step in isn't that odd, and they're more likely to generalize. It can be that we train in the clinic, and then we train at home, and then we train at the school. And you might find that when they're in the shopping center, the behavior starts to emerge spontaneously. Various sets of objects or stimuli, the more that you train, the more examples you use, the more likely that it will spontaneously generalize to stimuli or objects that you've never used before. The more exemplars that you use when you're training a client, the higher the likelihood that you'll get spontaneous generalization later to novel stimuli or novel conditions. This, of course, is going to depend a great deal on the client and how high functioning they are. Higher functioning individuals will generalize faster, and others who tend to function at a little bit lower level might require additional training before they start to generalize on their own. One of the problems that comes up when training generalization and discrimination is a tendency to become over-selective. Individuals with autism tend to focus only on one aspect of a very complex stimulus. So if the stimulus is too complicated, they will only respond to part of it. And so their ability to generalize beyond the specific stimulus that they've received is really compromised. In 1961, George Reynolds from the University of California, San Diego, did some research looking at over-selectivity in animals. He looked at birds. He used pigeons. He was one of the professors at the pigeon lab that I was trained in before I got there. He had retired before I arrived. And then Ivar Lovaas from UCLA and one of his former students, Laura Schreibman, who was the autism teacher at UCSD where I attended, they replicated some of Reynolds' work with birds using children with autism, who are famous for being more over-selective. So let me tell you a little bit about Reynolds' study. It's kind of a basic research study. It's not really an applied study. And so he had two stimuli. He had an SD that predicted food, and it was a red key light in an operant chamber for a pigeon. So it was a round red disc that had a white triangle on it. The S delta was similar. It was a green disc with a white circle on it. And they alternated these two stimuli back and forth randomly. The SD, the red with the triangle, producing food when the bird would peck at it, and the S delta, the green circle, producing no food when the pigeons would peck at that one. And after a while, the pigeons kept pecking the red with the triangle, and they slowly stopped responding to green with the circle. And then George Reynolds did a test. He separated these stimuli into 4 different components. So he had a red stimulus and a black background with a white triangle, and a green stimulus and a black background with a white circle. So he broke up, these are what we call compound stimuli, and so he broke them into their component parts and tested to see whether or not the birds would peck at them or not. With the S delta, what he found was that when he presented just green by itself, the birds would not respond. And when he produced just the circle on a black background, the birds did not respond. So they were able to, they clearly had learned both about green and the circle. But when it came to the SD, only one of the two aspects controlled their behavior. It was different for different birds. So some birds responded only to red, some birds only responded to the triangle, but none of the birds responded to both. And he was very interested in this, that the pigeons were individually being over-selective, looking mostly, when it was a combined stimulus, looking mostly at the red part and not really paying attention to the triangle, or vice versa. And so that was kind of an interesting study. And a little over 10 years later, Ivar Lovaas and Laura Schreibman in 1971 gave children with autism discrimination training, where they would press a little lever and they would be reinforced with little food treats in the presence of a red light and a white noise. So the red light would come on and there would be the sound shh in the background. And so in the presence of the red light and the white noise, they received reinforcement. And in the absence of the red light and the white noise, that was the S delta or the S minus, and that was extinction. So when the red light was on and the sound was there, they could get reinforcers. And when the red light and the white noise were turned off, they got no reinforcers. And what he found was that the children learned to respond to the S plus, to the SD, the compound stimulus, but when tested separately, only one of the two stimuli controlled the kids' behavior. So they were only responding to the white noise or only to the red light. And different kids responded differently. Some went for the light, some went for the noise, but none of the kids went for both. Normal kids, typically developing kids, responded to both stimuli by alone. They were able to learn it. And so that suggested that children with autism may be, like the pigeons, over-selective when presented with complex compound stimuli. And as a result, they need additional training to learn to respond to all parts of that compound stimulus. So when a client shows deficits in the ability to generalize, you might need to develop a protocol, a training protocol, to explicitly teach generalization. You might want to teach generalization across settings or across caregivers, like from the therapist to the parents to the peers to staff, or you might want to show it across individuals, different clients. So when you're working on putting together a generalization training program, there's a few things that you need to be aware of. The first one is that you select appropriate target behaviors. Behaviors that are likely to produce natural reinforcers after you fade the artificial reinforcement. So training them to do silly behaviors for artificial reinforcement for nothing more than the point of teaching it is really not very ethical, nor is it very effective. Useful behaviors are what we really want to train. We want to work very hard on establishing and then generalizing things like self-help skills and vocational skills and social skills and language. That's a place where generalization is really important. One of the things that can be really helpful is when you have a great deal of similarity between your training environment and your final naturalistic testing environment, your training stimuli and your final testing stimuli. So that's important. The closer they are and the more similar they are, the more likely you are to get generalization. And then the last thing that I want to mention, well, actually I have more things, but the last one on this page is the use of multiple exemplars in your training. So, and that just means multiple examples. So having multiple examples of the stimuli or the behaviors or the setting in which you want to see generalization, having more and more examples for them to practice in means that you're more likely to get spontaneous generalization later. Finally, these are just a few more factors that influence generalization training. Intermittent and delayed reinforcement will slow down your training. Naturalistic reinforcement will enhance your training. Self-monitoring techniques, having the individuals keep track of their own data, can really enhance acquisition and enhance generalization. And then finally, contrast effects. So training efficacy in one setting can actually slow down or decrease compliance in another one temporarily. So if you get good control in the laboratory or in the clinic, and then you go into the school setting, while you're working in the school setting, when the client comes back to your office, they're not as compliant. And so you see what looks like a little bit of loss of control over their behavior, but it does usually come back. Anticipating this effect can help you kind of deal with it when it arises so that you know to expect it and you're not caught off guard by it. Sometimes what helps is you do your initial training in the therapist's office, and then you shift to maybe the school classroom environment, and you start to see the clinical behavior kind of falling back into its old habits. So doing cross-training can actually alleviate that problem. So in addition to moving to a new environment, still running some sessions in the therapist's office can help to maintain that behavior. And when it's being maintained in the old environment, it tends to produce better generalization in the new one. All right. So one last slide. Generalization training can be used to train all three types of generalization. You can do response generalization, subject generalization, stimulus generalization. But remember that subject generalization may require additional modeling, and it may require some imitation training before other subjects will start to imitate and follow the lead of the individuals that are being treated. So it depends on what their functioning level is in terms of generalization, and kids who don't generalize spontaneously will require additional modeling and imitation training before they will spontaneously begin to follow the lead of individuals who are being treated directly. All right, so that's it for Chapter 7, and we'll be back to finish up the rest of Unit 5 shortly. Have a good evening.